Hi, this is Leetcode question. Put marbles in bags. This is the third question of weekly contest 330. You have k bags. You are given a zero indexed integer array weights, where weights of I is the weight of the ith marble. You are also given the integer k. Divide the marbles into k bags according to the following rules. No bag is empty. If the ith marble and jth marble are in a bag, then all marbles with an index between the ith and j indices should also be in the same bag. If bag consists of all the marbles with an index from I to j inclusively, then the cost of the bag is weights of I plus weights of j. The score after distributing the marble is the sum of the cost of all the k bags. Return difference between the maximum and minimum scores among marble distributions. So in this example here we have k equal 4, and that means we have 4 bags, and we need to distribute or divide this array of marbles into the 4 bags. For example, we can get these two to the first bag, these two to the second bag. So the first bag, second bag, and this is third bag, and this is bag number 4. The cost for the first bag is weights of I plus weights of j. I and j are the edges of the segment, so here we have weights of I is 1 plus weights of j is 2. Here we have, this is I, this is j, so 4 plus 7. For this one, 5 plus 2. And for the last bag, we have I and j the same index, so the cost for this bag is 4 or 1 plus 1, and the score for this distribution is the summation of all the costs. 4 plus 11 plus 7 plus 2 equal 9 plus 11 is 20 plus 3 23. This is the score of this distribution. Now if we take another distribution, for example, we can do this and this and this and this. So this is the first bag, this is the second bag, and this is the third bag, this is the fourth bag. Notice that no bag is empty, and these bags, these segments are continuous. That means the end of the first bag, we start the next bag with the index plus 1. For example, here we start bag 3 at the end of the second bag plus 1, and here we start for bag 4 at the end of index 3 plus 1. So the cost of this distribution is, for the first bag, it's I, the weights of I is 1, weights of j is 4, so 1 plus 4 plus, for the second bag it's 7 plus 5, for the third bag it's 2 plus 2, for the last bag it's 1 plus 1, and this equal 5 plus 12 plus 4 plus 2, which equal 21 plus 23. So the score of this distribution is 23. Now we need to return the difference between the maximum and the minimum scores among marble distribution. How can we find the maximum score and the minimum score? Notice that for k equal 4, we need 4 segments. Segment 1, and this is segment 2, segment 3, this is segment 4. And for segment 1, the start always is the start of the array, and for the last segment 4, the end will be the end of the array. So what remains is this element and this element, and these are missing. And remember that to start a new segment, so this is the start of segment 2, the index will be the end of the previous segment, which is segment 1 plus 1. So these two value should be somewhere neighbors on the array, and the same for these two, and the same for these two. And this means that to find the maximum score, we need to find the maximum summation for two neighbors. And in this case, for k equal 4, we need to find the maximum 3 values, because we have 4 segments and 3 pairs are unknown, and the maximum will be the summation of these 3 plus this one plus this one. So for example, if we have k equal 3, for k equal 3, we need 3 segments. Segment 1, this is the segment 2, segment 3, which is for bag 1, bag 2, bag 3, and again these are known, and we need to find the maximum 2 pairs. So we need to find k minus 1 neighbors with the maximum sum for the maximum score, and for the minimum summation for the minimum score. And to do that, we need to use priority queue, 2 priority queues. One is max priority queue for the maximum score, and one is min priority queue for min score. And we loop over the elements in the array, and we push to the array all the neighbors. So we push 1 plus 2 and 2 plus 4 and 4 plus 7, then 7 plus 5 and 5 plus 2, 2 plus 1. And for the maximum score, we need to find the best or the maximum k minus 1 pairs. So we set the count equal k minus 1. Now maximum sum, we add this to the maximum sum. So we find we added the 3 maximum pairs, and also we need to add the 2 weights on the corners, because as we said we have 4 segments. These 2 are known, and so we added them to the max sum, and from the priority queue we find the best k minus 1, in this case the best 3 pairs, and we do the same for min priority queue. We set count to k minus 1, we add to the minimum sum the minimum 3 pair values, and also the values at the edges of the array, and at the end we return the difference between the maximum and the minimum scores. So for this example here, the priority queue, the max priority queue, max, and here we have min. So we have this 1 plus 2 is 3, 2 plus 4 is 6, 4 plus 7 is 11, 7 plus 5 is 12, 5 plus 2 is 7, 2 plus 1 is 3. So the max priority queue will be 12, then 11, then 7, then 6, then 3, then 3, and the min priority queue will be 3, then 3, then 6, then 7, 11, and 12. Now for the maximum score we need k minus 1 best pairs, which is 3 pairs. 4 minus 1 is 3, so here we have, for the maximum score we have 12 plus 7 plus 11, this equal 23 plus 7, 28. And remember we need to add the weights of 0 and weights of n minus 1, so we need to add also plus 1, and this equal to 30, but this is 12 plus 7 is 19, plus 11 is 30, plus 1 equal 32. So this is the maximum score, and when we are saying 12, so this represents the pairs, this pair 7 plus 5, so this is 12, this and this. 11, it's 4 and 7, and 7 is, this one is 7, so we have 5 and 2, and as we said we need 4 segments, 1, 2, 3 and 4. The first segment has 1 and this is missing, then we have this missing, this is missing, so this one here is the first one, which is 4, so this is 4, and this one, the start is 7, and here we have another 7, and here we have 5, so for this one we have 5, and here we have another 5, and here we have 2, and here we have 1. So this will be the distribution for the bags, and the cost for the first bag is 5, for the second bag is 14, for the third bag is 10, and for the last bag is 4 or 3. 2 plus 1 is 3, and the summation for this is 5 plus 14, 19 plus 10, 29 plus 3, which is 32. Now this is for the max sum. For the min sum, let's write the array again here. We have 1, then 2, then 4, then 7, then 5, then 2, then 1. So for the min, we need to select k minus 1 values, which is 3 values. So we have 3 plus 3 plus 6 plus the 2 values at the edges of the array, which is weights of 0 plus weights of n minus 1, and this case 1 plus 1, and this equal 3 plus 3 6 plus 6 12 plus 2 14. So for max score we have 32, for min score we have 14, and the answer will be 32 minus 14, which equal 18. So this is the final result. And again, for this 14, how we make it, remember we have 4 bags, 4 segments. Every segment need start and end. And for the first segment, it's always the first value, which is 1. For the last segment, the end is the last value in the array. Now here from the priority queue, we find 3, and this is 3, value 3. So we have, this is 3. So we have these 2 pairs, and we take the first one. So this value here is 1. Then this value here is 2. Then the priority queue give us also the value 6, and 6 is here, which is 2 plus 4. This is 6. So we have 2 pairs, and so this is 2, and this is 4. Then the last pair is a 3, which is this 3. So we have 2 and 1. This is 2, and this is 1. And the summation or the score for this is 1 plus 1 is 2. And for this pack it's 4. For this pack it's 6. For this pack it's 1 plus 1, 2. And the summation for all of these value is 6 plus 2, 8 equal 14, which is the value we get here.